morning, everybody. Give me a second to turn my lights on. There we go. All right. Hope everybody's doing good today and everybody's ready because tomorrow we have a test. So make sure you're all there. Exactly 24 hours from now, the test begins. So yeah, it's a good morning to my puppy too. All right. So today we're going to continue where we left off yesterday, which is talking about more about functions. And yeah, that pretty much will be the entire day, just full functions. If we have extra time, we can talk about maybe arrays, but I kind of want to just practice a lot of function stuff. We can really get that, because I mean, that's topics 8, 9, and 10. That's all chapter 6. And after that, we just have to do arrays and structs, so then we'll be done. So we can spend the full day on functions and really get it down. In case you were not aware, yesterday we did have a small review session for the test. It's not on YouTube, but it's on Twitch. So if you're watching on Twitch, then you can go somewhere up there and click on videos, like history of videos, and it should be there as a separate video. It's called test review. So yeah. Okay, well, like I said, good morning, and let's get going on this. So, as you can see, this only says functions, because that's all I think I will cover, but we'll find out. So anyways, let me just go ahead and jump right in then. Unless there's any questions. And then also I'll go over the homework. Yeah, I'll go over the next homework. We are right now in homework 6, and there's 10, so we're about a little bit past the half amount of homeworks. But I'd say in terms of actual workload, we are not even halfway there, because the assignments are going to get a little bit bigger. Assignment 7 is the only one that I have right now for a due date for the 27th, but we will cover arrays on Thursday, so you will probably have both 7 and 8 to do this weekend. So I have opened here the assignment, and that one is made by Dolly, so we'll kind of work our way through that. But it does seem pretty complicated. So okay, anyways, we'll go over that after we finish functions. So I guess we might as well do a quick review of what we covered last time, since it was a lot of material. So let's look at the code from last class. So we were talking about how we want to be able to reuse code and make code modular. And one of the ways that we can achieve that is using functions. And so functions are little pieces of code that run on command. And you can basically call a function anytime you want and feed it some input that it requires. And it doesn't have to have any input, as we saw. Like if you have something like just a function that does something to the screen, like prints a greeting message or something, there's no input and there's no sort of return value, there's just some output. Obviously, if there is no input and there's no output from the function, as in return value, there must be some kind of output, like maybe it prints something to the screen or changes something somewhere else, because otherwise, what's the point of the function? So something has to happen in the function, right? I mean, yes, you could have a function that does absolutely nothing. We can write that really easily. You can just say void foo, and then just that, and there you go. That is a function that I can actually call, but it will do nothing. It will actually internally, it'll allocate memory and do all the processing that actually involves getting a function running, but you will not actually see any change in your code because it's empty. It's just a blank function basically. And that's okay. I mean, if you're writing code and you're sort of working your way through, like I did that yesterday when I did that big example with the tax stuff, you can write all those functions like this and just leave them empty so the code compiles. And then you can go back and start adding each of the bodies of the functions, because we call that the body. So for example, I know that foo is going to eventually say hello world, but you know, first I'm gonna write my main and create all my functions out. So maybe I have foo that says hello world, and maybe bar that says good morning. Okay, and I know that I'm gonna do that, so I call the functions here. Of course, I can't compile this code. It's gonna tell me that they're undefined references, or was not declared. Yeah, because this one was declared. And then if I just want to make sure it compiles so that I can start working and seeing stuff as I make progress, because let's say I'm ready to work on foo, then I can go ahead and just do an empty body. And now I can compile and I can run it. Of course, nothing happens, but now I can start working on foo and be like, okay, I'm going to go ahead and write hello here. And I'll just run our hello there. Maybe I'll do world in the second function. And so now I can run it and I can see the hello. And so this is sort of a placeholder so that eventually I can go in and add the body. So like later on when I get to this function, I can actually say, I'm going to do world actually instead there. And then I can compile that as well. So there is a purpose of just having an empty function, not necessarily for the final product, but sort of as a placeholder where you're going to go ahead and add code later. You can also even write, a lot of people are writing a comment saying, if I can write a comment, to do. And that just sort of reminds you like that you have to do something there. So yeah, that's a good usage of an empty function, which is possible. But anyways, back to this. I showed you that functions can take parameters, and they can take parameters, so they're basically their inputs, and then they can return one value, and they can return that value using the return keyword, and then depending on the type here that's listed in front of the function name is the type of value that they can return. So this is float, so this will return a floating point value. If this is int, it will be a integer. If it was a string, then it would be a string. So it can be any data type that you want, but it can only be one of them at a time. And if I try to return something that is not this data type, it will try to coerce it. And if it can, then it will. If it doesn't, it'll give you an error at compile time and say it's not possible to coerce this. For example, if you had a string here and you try to return like an integer, I think that will happen. We can very quickly do that. So let's say that foo returns an int and bar returns a string. And they can still see hello, but let's say that here we return a word like hello. Okay, and then this one, of course, we can let's actually return a normal string. We also did talk about that the way you capture the return value here is you can save it into a variable, you can cout it, but you can also just throw it away. Like you don't save it anywhere, it just kind of falls into the void. So anyways, this will have a problem because you're trying to convert a string, which in this case is a constant car pointer, because this, even though this is a string, it's a literal, and so that's why it says const in front of it, because the literal doesn't change. But either way, we're trying to convert that into an integer, which is not allowed. On the other hand here, I don't know why I added this end line here, just by practice. So ignore that one error. So there we go. Okay. So invalid conversion for that. Now, if I change this to an actual string, I say string equals hello, well, string str equals hello. It's hard to type like tilted because my keyboard is this direction. I have like turn this way, I would type so much easier. Okay, and so now you can see that it says cannot convert string into int. And by the way, notice something here about this. It says stdcxx11 string. So this is because it's a C++ string. Remember with the file streams, you got to make it into a C string. Let's do that here, just to see how the name changes of the data type. You do that with this function, right? So if we run this again, now you can see that it changed from this to what we had before, const car, right? And that's what we kind of consider a C string, which is what file streams accept. So you can see that even though they're both strings, you can see the difference in what the data type is telling you the errors from, which is why this is the kind that file strings fopen accepts, and this one does not accept it. So just thought I'd show you that. Wow, this is interesting. But anyways, of course, this will never work because we have here this. So actually, if we do this, is it gonna complain? We'll see. No, it's okay, cool. As you can see here, it says hello world world because we have two worlds here. So if you comment this one out, then we'll say just hello world. And so what is happening here is we are returning a string because it accepts a string. But as you can see, it can't coerce an integer into a string. So that one had a hard time. If you want to actually see an example of coercion, we could change this to integer and then maybe return like a floating point value or a double. So this is a double because there's no f. And if we put an f here, now it would be a float. But like that is double by default. Just FYI. So as you can see, the same thing, but in this case, we are returning a value. If we want to see that value, instead of throwing it away, we can like see out it like this. And then it's going to be in the same line as the hello because there's no inline, but you'll see it. Oh, never mind. After the world. Yeah, because it's right. It's, oh, this brings up a very good point. So, why do you guys think that the 6 came out after hello, even though it's the first line here? That's a really good question. That would be, I mean, I did the test already, but that would have been a great question to put on the test, actually. So why did the word hello print before the 6? And I guess while we're at it, why did the word world print after the 6? Like, why that? If we are seeing, the first line here is cout foo, and foo just returns to 6.5. So shouldn't I not get 6? I mean, well, let's cut to the chase for a second here. The 6.5 becomes a 6 because it's being coerced as an integer, right? So that we know. But why is it being printed right there and not before if it's the first line in main? What do you guys think? Any ideas as to why that is happening? Because return didn't happen until the end of main. Nope, that has nothing to do with it. And by the way, I guess I should put a return here just for some good practice. Because hello comes before the return. Yes, that's much better answer. That is very true. The hello comes before the return because the way this code is running is it starts at main, but when it sees this line, before it can see out anything, it needs to resolve what this function is going to do. So it calls a function which generates a string, prints the string, so that's how we get the hello first, returns a 6.5, which becomes a 6. Now this gets a 6 back, and now it can see out it. So that's why we get hello, 6, and then we get to this line, the bar. The bar is supposed to print something, but it cannot print it until it resolves this. So it calls bar. Bar returns world from us as a string, so we get that back world here, and now we just see out world. And then, of course, we see out an end line. So that logic is very important that you guys understand how the control flows from the program. So we start at main and we end at main, but as we go through the functions, main halt, and more importantly, it's going from, in this case, from right to left, because it cannot do the cout until it knows what foo returns, because foo is a value returning function. And for it to know what foo returns, it needs to actually compute that. It's like saying the answer to your question is f of x is equal to x squared plus 1, given that x is 2. You can't know the answer to the question until you actually plug in 2 squared plus 1, which is 5. And then you know that the answer is 5, right? So you can't skip ahead to knowing that the answer is 6 until you compute it. Obviously here you're not really computing anything, you're just getting a hard-coded value. But, you know, imagine that there was actual math involved to calculate this. And it doesn't matter for the computer because it's going from top to bottom, so it's going to run these in order until it gets to the 6.5. And you want it to run in that order, because if the computer was smart enough to say, oh yeah, this returns 6.5, it would skip that, and then you'd actually never get the hello printed, and maybe that's not what you want, right? You actually want it to be printed. Remember, there are some times that the computer does take shortcuts, like that is called short circuit evaluation, but that's with Boolean logic, completely different example. But that can create side effects, such as if in your Boolean logic, imagine that you had something like this. So imagine somewhere in code, you had if foo is equal to see, how do I want to do this? Yeah, okay, I got it. So if foo is equal to 6, which we know will be true, or 1. Okay, so we're saying 1 or this. Here's the thing. When it gets to this 1, it's like, yeah, this is true, so I don't need to run the foo. So then it goes into the if statement. But what's going to happen then? The hello's not going to get printed. In fact, actually, we can run this. Yeah, let's just plug it in main. So let me comment these out. I'll leave the end line. So if you have something like this, and then here we have an if statement, okay? The fact that the foo is in here means that you would expect it to have compare 1 with whatever foo equal to 6 is. Foo equal to 6 has to be, you have to look at what foo does, which then you have to run this code. The issue here is because the computer sees a 1 here, it's just like, yeah, we're gonna go in the if statement. So it's gonna just ignore the foo. As you can see, when I run it, all it says is an if statement. It never prints out hello. And that's because of short circuit evaluation. If I wanted to guarantee that foo got actually ran, I could flip it around like this. But that's not truly solving the issue, because I mean, while it worked in this scenario, suppose that on this side I had 1 or 1 and bar. Bar doesn't do anything. Let's just do 1 and foo again, which would be false technically. Actually, that's a horrible thing. That would actually be, that would be true, because this would just be true and 1 would be true. So that would evaluate to true. Yeah, we're missing a parentheses. Here we go. It's horrible logic there. But anyways, it shows a point that only this foo is being ran, because once this becomes true, then this no longer needs to be verified. So that is called side effects, and it's very dangerous for you to be doing these kind of things. Only if you're not worried about this running, which means there's nothing happening here other than computing the return value. But if there's some sort of cout or something that's supposed to be changed, that's when you run into problems. That's a problem with your coding more than with the language. If I switch it to an AND, then I get them both, because an AND guarantees that I have to check everything. But that's changing the logic, right? What I really want to do here is an OR. I can't just switch to an AND just to guarantee that the code runs. I don't want to do that. What I want to do is, if I really want this to happen like this, is I need to take out all the cout stuff from here and just leave the pure math, so that I'm not worried about whether it runs or not. And I can do the couting somewhere else that I can know for sure that will run. So be careful about that stuff. I posted, by the way, on Discord a quote from that I got from Dolly for a person that was talking about writing code, and this is the guy that created Ruby. So he's very rich and he's pretty smart. So there is value in what he says. And he says that software engineers should really be called software writers, because what they're doing is writing at the end of the day. And it's not enough for a writer to know the dictionary. It's not enough for them to know the theoretical order of how to do things, like how to write a paper and that kind of stuff that you learn in an English class. That's not enough. The only way that a writer can become a good writer is by both reading and writing. So a programmer, the same can be said. The only way that you're going to become a good programmer or a proficient programmer is to be able to read a lot of code that you see online from other places, and to write a lot of code, because that's the only way you're going to discover your inner voice, per se. And in the same with coding, is you're going to discover your style, and more importantly, what works and what doesn't work. So yes, this is an engineering college class, but I think that it's a very good comparison to say it's more of a writing class. And you know, nobody can teach you how to be a good writer. They can only guide you and sort of point you in the right direction, but you have to sort of develop that yourself. So the same with coding. And it goes back to what I said a while ago, which is take pride in your code and make it good. So this is how you don't take pride in your code. This is horrible code right here, right? So, but yeah, anyways, if you want to read the full quote, which is not that long, it's on Discord on the general chat. So, or CS135 general. But actually, I'll post a link too on Twitch. That way it gets preserved with the video. Because I am going to leave these videos forever. Like, I want to see them when I'm old. Which will be never. But anyways. So you can check that link out later. And read it. It's pretty good. It's kind of inspiring. So, okay. Anyways, what else did we talk about last class? We said about the return type. We actually finally figure out why return 0 is here, because main is a function, and that return can be read by other programs. And I think that was pretty much it. I guess should point out there are three main types of a function. The main components of a function is we have the return type, which can be void, which means nothing gets returned. Then we have the identifier, which is the name of the function, which has to follow the same identifier rules as variables. And then we have the parameter list. Now, within the parameter list, we have different data types. So the way you have each parameter is you put your data type, which, by the way, you can have 0 parameters, such as the case like this. But if you do have parameters, you have to list first the data type of the parameter and then a unique identifier name, again, following the variable rules. Then you put a comma, and then you do the same thing again. So data type, identifier name, and so on. And you can have as many as you want within reason. I do believe there is some sort of limit. It just makes sense that there would be, but I don't know, I've never ever hit that. And you should never hit it. It comes back to the idea of you're probably doing something wrong if you have that many parameters. So yeah. Anyways, in terms of naming conventions, when you have a function call, that is when you're calling code, and that means you're sort of activating, or you're summoning the function, just to avoid using the word call in the definition. And these parameters that you're passing in, we call that the actual parameters, whereas when you're defining the function, these are called the formal parameters. The other thing we talked about is that just like with writing, I mean, yeah, we did say that with writing, right? This is so much like writing. So I gave the example with writing. I was talking about like the Beatles, right? And then I said, like, in the first paragraph, you introduce that what you're talking about in your paper is the Beatles, right? And so later on in the essay, the second paragraph, you can say they. And they is assumed to be referring to the Beatles. Same thing here. If you are referring to a function, you first have to declare the function. And you don't have to necessarily define it, because C++ has the ability for you to create a function prototype, which is kind of like a promise to the compiler saying, like, look, we're going to have this function. It's called greeting. It's going to have 2 parameters, so you know exactly what it's supposed to expect, and the return type, so you know as well for that. That way you can ever check around that part. But I'm not going to tell you what the function actually does, because you don't need to know for the code to compile yet. And then it's going to sort of Googling 256's general max parameters. That number is probably because it's a power of 2, and maybe it's kept in like a short or something. So that must be something related to memory, because anytime you see something power of 2, it's very computer sciencey, and so maybe that's why they decided that. Like, that's why they didn't pick 250 or 260 or 200. So interesting, 256. I don't know that. That's a cool thing to know. You know, I should make that, not this semester, maybe I will, but I don't promise. But I should make that like some sort of bonus extra credit at some point in like a test or something. Just to see if anybody knows it, because I mean, I don't think anybody ever checks that. But that's pretty cool. Thank you for finding that. But anyways, so back to this. When you have a function prototype, again, you're promising the compiler that you're going to tell it what it is, but you're not giving it the body, because it really doesn't need to know what it happens. As long as it knows what to give it and what to get back, that's really it. Like, it's a black box. It's like, you know, in the sense of like, you don't know what happens in there. You just know that you're going to get something out of it, and hopefully it's a good thing. And so that's why the compiler is accepting this. However, that doesn't get you away with just never ever refining it. You know, this will get away with the ability to be able to just put a prototype and then have the function calls to it. As here we have somewhere greeting. Well, I guess we commented out, but if we call greeting there, then it's okay with that. Eventually, though, before it gets to the end of the code, then you actually need to give it the function definition, which is what this is, which is made up of your function, again, the return type, identifier, parameter list, and then which is called the function heading. There we go. I remember that name. And then we have the function body. And with the body, again, you now it's the time to actually really define what is happening, because the compiler, while it's all cool with you just giving the prototype for this, before it ends, it needs to make sure that the code in the body is actually valid, or it's good to go. So it will complain if it doesn't get to the end and doesn't see it. And I did show you some of those errors where that happens, where like the way that you can usually have that is if you misspell the name of the function here versus how you're using it here versus the prototype, and then everything gets confused. So that's, I would say, the most common error that I face if I go ahead and do this kind of system, because I will uppercase something or I'll put an S at the end, like greetings. I think I actually did that like yesterday. So yeah, that's all we talked about. And the big cliffhanger last time was what happens if we want to return more than one thing, right? We want to be able to return more than one thing here. Some languages allow you to do that. They allow you to comma separate return. So I can do result comma 1, and that means I return whatever is in result and a 1, or result comma b if b is not the variable. So some languages allow you to do that, which is cool, but kind of scary at the same time because I'm not used to it, at least. There are, however, another way that you can return multiple things. And I'm not even talking about how when we talk about objects, well, we won't really talk about it, but when we talk about structs, you can use a struct to return multiple things, which is how I did the example with the taxpayer problem, even though I just kind of hand-waved the struct concept, and we will talk about it eventually. But with what you know right now, there is another way, and that is the main focus of what I want to talk about for the next half an hour at least. But to get to that, let me give you a theoretical function that I was thinking about earlier as an example, and that is, let's write a function called magic box, and this magic box is going to take two parameters and it's going to print them out, and then it's going to swap them, so flip them around and then print them out again. Okay, so let's just go ahead and write that function. And by the way, very off topic, but not off topic really, the name foo and bar that I pick here is not out of my crazy head. Those are very, very popular names that people like to give to sort of a generic function. Not that you want to use it in your program, but it's more of like if somebody's giving you an example of something, they use the word foo and bar. Those are like Timmy. I guess that's a really typical name for like when you say, imagine Timmy going here or Timmy going there, right? I think I've heard that a lot of times as a generic name that people use when you're talking about an individual per se, right? Or like John Doe, okay? Yeah, John Doe would be an example of that. So when you see foo and bar, those are because like somebody's giving you an example. So just sort of, the reason to know that is because it's just lingo, CS lingo, foo and bar. So you might be wondering, like, are we all interconnected in the brain that we always use the same foo and bar examples? Like you go on Stack Overflow or something, you see people using foo and bar, and you're like, where's this foo and bar coming from? What is it? Somebody sometime came up with it. You can probably Google and find the origin. It was probably something randomly simple, but yeah, that's why foo and bar came. So I thought it would be a disrespect to the CS world to not throw foo and bar as an example somewhere in class. So now we did. Cool. It's like Hello World. It's like, yeah, the same concept as like how you always do the same program. The first program is Hello World. Yeah, foo and bar, the same idea. Okay, so now we want to write a non-valid returning function, which is called a void function, called magic square. Gotta uppercase this so it looks kind of nicer. And then the two parameters, we'll do two integers just for now. Okay, so that's going to be a little function prototype. And then let's go ahead and actually move the foo and bar beneath here. We don't really need it right now. And we're not even using, yeah, we are using them. So I guess we'll do a prototype for each of them. And then string bar. Let me make sure everything compiles before I go any further. Yeah, okay. I don't have any errors. All right. So now we can go ahead and write our magic square function. I'm going to write it down here beneath it. Why not? You obviously, if you're doing the prototype, it's because you want to put it after you call it. But we're not really worried about that now. We'll eventually move it down. By the way, you don't have to give the identifier names here, but you can. If you do, though, sometimes I have seen situations where you run into issues by not using the same names later on. Let's see if we're okay here. We're okay here. So, however, this is again bad practice because now you're really confusing people. You see an A and B there, and then you just flip them. People are going to be like, what? So either commit to the name like that, or just don't put any names to avoid any confusion. Okay. Most of the time, what ends up happening, why those names appear there, is because a lot of people, when they need a prototype, they just Control-C, Control-V, put a semicolon, bam, prototype done, right? That's usually how that happens. So, anyways. Okay. We want, so I guess, let's go ahead and write comments of what we want to do first. So we want to print out A and B labeled, swap them, print them out again. So those are the three things we want to do. We don't need to put a return in the function because it's a void function, and it kind of just sort of has it built in, and the only time it's useful is when we want to return early from a function. But you know, I just thought I'd put it there to refresh your mind. Okay, so print out A and B labeled. We can do that, no problem. Let's go ahead and say cout A. I'll do A uppercase because I like it. And then A. And then maybe we go ahead and do cout B, B, and then an end line. Okay? So that takes care of the first part. In fact, we can even try to run that part and see if it works before we go any further, because it's good practice to sort of divide and conquer. So we divided our problem into 3 smaller problems, and now we're working our way through each of them. Nothing prints out because we have not called the function. So let's go ahead and say magic square A and B. We could hard code it, but I'm going to create some variables here for a reason that will become apparent later on. In fact, they don't have to be the same names. They could be, but let's not make them. So let's put some test values. Let's say 10, and then, or maybe, I know what I'm going to do here. Let's do 21 and then 12, like that. That just looks prettier by lining up the equal signs. Too few arguments. Oh, I forgot to actually put them in. So left and right. As you can see, that compile error is pretty clear to understand what was happening. Cool. We want to put a space here, maybe 2 spaces. There we go. I like that. Okay. So now we have A and B. Next, we are going to do. What are the 3 steps in the magic process? First is the show, the turn, and the prestige, I think. The first one's show, turn, prestige. Is that how it goes? The pledge, yeah. So this is a magic trick. This is the pledge, and then the swapping is the turn, and then this is the prestige without the U. I don't know if you guys have seen that movie. Although I don't think it originated from the movie, but there's a movie called The Prestige. It's pretty cool. All right, so we have the pledge, which is to show the A and B. The magic trick is, we're gonna say abracadabra. Abracadabra. Of course, we still need to swap them. How we are actually going to do that is magic, right? How do we swap them? Can we use this? Can this be a successful swap? Yeah, we could try it. We can print them out and see what happens. To print them out again, we can just copy and paste that code. Or better yet, we could have created a function that prints them. But hey, maybe we'll do that later. We'll upgrade it later. So that is the prestige part. Let me just make this nicer looking. Okay, there we go. So we got and then I guess this one maybe. There we go. Okay. So now we get this abracadabra, and now we get 1212. That's not much of a magic trick unless your idea was to clone somebody or something like that. But yeah. So this is not a very successful swap. Okay, can we then? Okay, maybe we gotta just do this. you know, send A to B and B to A, right? Maybe this will work. I don't know. Let's try, and it's going to fail. We still get 12, 12. What do we need for this to work? What we need for this to work is we need a temporary variable. Swapping requires a temporary variable because what's happening is this. When we overwrite A with the value of B, we have lost A. Like we just completely lost it at that point. It is gone forever. So what we need to do is we need to create a temporary variable in which we store one of the two values. So let's say we store A in there. Now we can go ahead and overwrite A with B like that. And is that enough? Not quite. We're still getting 12, 12. Because now that B got assigned to A, so A has now the value of B, but now we got to update B with the value of A. We can't do that because we just overwrote A, but we have A, or the old A, in our temporary variable. So what we need to do is we need to assign the temporary variable into B like that. And now this should work. Bam, magic, guys. We went from 21 to 12 to 12 to 21. So there you go. There's your little magic trick. Okay, cool. Swapping is a very, 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 very important thing when we talk about sorting. It's quite a trivial concept, as you can see. Just 3 lines of code. Don't memorize them. Understand them. That's much better. But let's go ahead and push this further, because I mean, so far we haven't really done anything new. Okay, let's go ahead and print out in main before and after the function call. Okay, so let's go ahead and do cout, and maybe for this one we do a function that actually prints things out, like I was kind of promising you. So we're gonna call this print, just print. Why not? And the print function is gonna take 2 integers and it's gonna print them out. We'll call them A and B, why not? Okay. So now we can call print before the magic square happens, and then we can call it after the magic square. Ah, yes. Maybe I can zoom out a little bit, because the code is getting a little bit wider, and so we're gonna run into problems. There we go. That way you can see a little bit more code. Let me know if that's too small. And maybe we, yeah, we don't need to see the bottom, so like maybe there. There, okay, so now we can see everything. Okay, so cool. So now we got print left and print right. Okay, and so, oh no, you still can't see that, damn it, right there. Okay, like that. All right, so we got print left and print right. Obviously, there is printing happening in here, so let's go ahead and comment out the printing that's happening inside the magic square. Or no, let's leave it, but let's label it as inside the square by putting a cout statement saying inside square function. We'll put it at the beginning of the square function, and then in fact we'll say start square function. It's probably smarter name for that. And then we're going to put another print statement at the end of the square function called end square function. That way we can see each of the couts because they're going to look the same. Okay, so let's go ahead and run that. Okay, so let's take a look and understand what this is doing. So I'm not going to put it over here to the side so we can see you like that. Okay, so first we print out A and B. That's coming from the print function, and it prints out 21 and 12. And then this piece of the code is inside the function, and then this is after the function. So once the function starts, we print out A and B again, which are 21 and 12, right? That's our left and our right. Abracadabra happens, and then they get swapped, right? They get 12 and 21, and the function ends. And then we print out left and right again, and we get 21 and 12. I want you to notice that outside of the function, 21 and 12 do not get swapped. Okay, that's very important because the variables left and right, when you're passing them into magic square, by passing it, the better way of sort of defining that is more of copying them. Int A and B are local variables in your function, which are your parameters here. The A and B are the parameters. Okay, they're local variables here in the sense that they only exist inside of this function, and when the function ends, they disappear. Also, the way they get initialized is from the values that you pass from A. So really, you're copying left and right into A and B. You're making a copy of them. You're not using the same data. Okay, it's like if I tell you go do something and I give you some numbers because you're gonna need my social security number. So I give them my social security number, they go do something and that. I'm not just giving it to them and then I lost it forever if they do something with it. No, I'm giving them a copy of it. Of course, don't give out your social security number like that. But yeah. So essentially, when they do the swapping, they're swapping on the copy and is not affecting the original data. Okay? This is called passing by value. Let's write that down somewhere here. Yeah, not really there because I don't think we're gonna write anything else there. So maybe just here. Pass by value. And this is making a copy of the parameters for using the function. Passing by value is very useful, but it's not quite the most efficient because it has to make a copy, right? And copying things takes time and takes space too. Additional space. You have two instances of the data. However, you can play all you want with the data and you're guaranteed not to change anything from the original data. So like I can fiddle around the social security number and scratch it and do whatever I want to the card because it's just a photocopy per se, okay? It's a valid photocopy, but it's just a copy. Now, the original problem where this whole thing came up, if you remember, was because we are trying to get more than one data back from a function, right? If with a valid returning function, we can only return one thing. What we're trying to do is find a way to return more than one thing. And one of the ways we could do that is with a parameter, right? Because here, technically, we want to be able to return left and right. We could return left or we could return right after they get swapped, but we can't do both. So how do we return more than one thing so that this swapping can work? And that is done by the other way that you can pass values to a function, which is called pass by reference. As the name implies, passing by reference would be the equivalent of you actually giving, not necessarily your real social security number, but suppose that you only had one copy of your social security number stored. Because it's very important and valuable, you keep it in the bank, okay? And so in the bank, you can change it because it's just a piece of card. You can scratch numbers and change your social security number if you wanted. But the point is that it's kept in a secure location in the bank. And in addition, to being able to access it and changing it, you want to be able to have quick access to the social security number. So when the person asks you, because they're going to go to the DMV or to the IRS to do some paperwork, and you give them out the social security number, you can't just give them the card because you don't have it, it's in the bank. So what do you give them? You give them the phone number or the address of the bank. That way, if they need to go and access your social security number, they can call the bank or they can go to the address and actually read the data from it. And because they have direct access to the original one, they can even change it if they want to. Okay? So passing by reference means that you're passing the actual location of where the data is stored, which means that not only can you access that data, but you can also modify it. And if you modify it, it's going to change the original data, which means that if you go and scribble and change my social security number, and then later on I go to the bank myself and check it out, it's going to be changed permanently. What are the advantages of this? Well, if what you're trying to do is just keep one instance of the data that you can modify in different spots, then this is the way to go. As you can see, this is the way that we will achieve returning multiple things from a function. But furthermore, because you're just passing an address or a reference as it's called, it takes very little space. A reference is just the actual physical location in memory of the data, the actual address of your RAM stick where the data is being stored. That's what you're passing. That address is a certain size, and it doesn't matter how big the data that you have is. Obviously, we've been dealing with small data types here, like an integer, a double, or a float. The biggest thing you've seen is a double, which is 64-bit. So the point is, but if you had something bigger than that, like when we talk about a struct or something, and you're just passing an address, you're only making, yes, you're still copying something, because you have to copy the address down. Like, you know the address somewhere in memory, or you have it written down somewhere, and then you give them a piece of paper and you write down the address of the bank. So you're still making a copy of something, but you're only copying an address versus copying the entire data, which may be bigger. It's possible it's the same size. If you're just copying an integer and then you're copying the address, they're actually the same size. So not much advantage gained there if you're just doing it for space-saving purposes. But if it's a big piece of data, like when we talk about an array, or when we talk about a struct, or in 202 when we talk about a big object, then yes, passing an address is much smaller and sort of faster, right? But more importantly, by passing the address, I can actually modify the source and permanently affect the program. So that's exactly what we're going to do so that our little swap function here works. So how do we pass by address? Well, there is an operator in C++ called the address of operator, and you use the ampersand to specify what is the address of. So if you want to pass these two parameters by reference, all you gotta do is put an ampersand in front of the variable name, like that, after the data type. You can also do it that way. They both do the same thing. It's your preference as to which you choose. I personally actually like the first one because it makes sense to me to say that the integer is passed by reference, by basically seeing the ampersand next to the data type versus seeing it next to the variable, but that works for me. All I ask is that you choose one of the two methods and you remain consistent. This is of course not consistent, but I'm putting it this way so that you can see that both work, but commit to one of them. Okay, tiny change, but call overloaded. What did we do? Oh, okay. This is good code, but now we run into a problem here. Our prototype is different than our function body and heading and body here, the function definition, because the body, the prototype says these are being passed by value. These are being passed by reference, so they'll match. And so the compiler gets confused on what you're trying to do. It says overloaded function magic square is ambiguous because it thinks that there's two functions and it doesn't know which one to call. This is the situation where it can't resolve. That's okay. We just gotta put the ampersand on the top too. And now we should be okay. So I'm actually glad that error came up, because you gotta put that in both the prototype and the body. And now the moment of truth has arrived. Will the magic work? And it appears, ladies and gentlemen, that we are indeed magicians, because we started out with 2112. We went into our function, 2112 again. We used the magic word abracadabra, and now we have 12 and 21. The swap happened, but that happened before. The real question is, did it happen outside the function? And the answer is yes. We have successfully swapped 12 and 21, not just in the function, but in the original one too. So, well done. And so we have a question. So the ampersand makes it edit the original value instead of a copy. I don't want you to think of it that way. I want you to think about the real reason why, which is when you use an ampersand, you are passing that variable by reference, which means you are passing not the variable itself to the function, but the location of the variable. Therefore, when you're modifying code in the function, you're modifying the variable at the location given by A and B. which is the variable that is being kept in main. So while yes, when you put the ampersand, you are indeed modifying the value that was passed into the function. The actual values are the variables are passed in, not copies of them. Don't think of it that way, because you will not truly understand what's happening. And then when we get to more advanced stuff, especially when we talk about if we talk about pointers now, but if not when we talk about in Tool 2 about pointers, you'll be very confused. So it's better now to sort of embrace and accept the idea that we are passing the address of the variable and not the variable itself. Whereas before, when we were passing by value, we were passing actually a copy of the data, whereas here we're passing a copy of the address, not the data. So you're always copying stuff, but before we were copying the data itself, now we're copying the address of the data. So make sure that you have a big understanding of that, because it's very, 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 very important. Maybe not now, but when you get to Tool 2, it's insanely important when you talk about pointers and stuff like that. So yes. So anyways, this is passing by reference, and it is very, very useful because, as you can see, we have found a way to be able to have a function modify multiple things at once. And right now we're just using it to swap, but we could develop a function that maybe the first 3 parameters are just in, and then we have 2 out, and those could be, for example, for computing stuff. So let's go ahead and maybe come up with a function like that. So what math equation requires multiple inputs and gives you 2 outputs? We could do coordinate computations, but that's going to take a while, like Euclidean distance. Anybody have any suggestions on what you want to do for that? All right, I got it. Something simple. Let's say that we're trying to compute the area of a rectangle and the perimeter, both in one function. Of course, such an idea would be better to split into 2 functions, one that computes the area and one computes the perimeter. But suppose that you were insistent on creating them both in the same function. Okay? So, yeah, let's go with that. So, I don't even know what I'm going to call it, because otherwise I would call it like perimeter or area, but now we have both. So, area perimeter is kind of weird. So we'll just call it a square calculator or rectangle calculator. I don't like this example, because really what you want to do with this is you make an area calculator. I know what I'll do to make my life not as painful. We'll create both functions, but then we'll call the functions inside of the function called rectangle calculator. Yes, that's a good idea. I like that much better. So let's go ahead and create a double get area, and this requires length and width, which are integers. But no, let's make everything doubles. We don't use a double as much as we really could. And of course, this is just to return double times double, right? It's length times width. Doesn't really matter which one's the length and which one's the width. So no worries there. Except don't call them doubles. You should call them something else. A and B. Actually, let's be good programmers and use more meaningful names like L and W, which is length and width. Okay? Cool. Now let's do the same thing for the perimeter. Get perimeter. That one again requires a length and width. Here, let's put a space there. Why not? Just so you know that you can put a space there. And that one is going to return length times 2 plus width times 2. That is going to give us the perimeter of the rectangle. Also, this could work for a square too, by the way. So, yeah, cool. All right. So there are those functions. And now let's create our bigger function here, the rectangle calculator. The rectangle calculator is going to take the length, is going to take the width, and then is going to return to us the perimeter and the, so I guess we got to commit to one data type here. So we use the doubles for these. So these are kind of our input parameters, and then we got our output parameters, which are a double for the perimeter and then a double for the area. Okay? And then in our main function, we'll just do it at the top. we're going to create a variable A and a variable B like that. You can do multiple variable declarations like this with a comma. And then let's go ahead and set A to be 3 and B to be 2. That's an easy multiplication. I think we should all be able to do that one to confirm by hand. And then we are going to go ahead and we need to create variables that can store the answers actually. So yeah, we need to create a, shoot. Okay, let's change the variable name so that we can have an A for area and P for perimeter. Of course, you would actually want better names for this, but since we are under a limited amount of time here for teaching, I cut the corners with the variable names. Rectangle calculator, we're going to pass it the length, the width, the perimeter first, because that's the perimeter that requires. As you can see there, it says right here, perimeter, and then the area. And then we do want to print out, let's print out everything so we can see it. So we're going to print out the length first. Then we're going to print out the width. Then we're going to print out the area. And then we're going to print out the perimeter. Okay. That should, let's just leave it like that and let's run it. We haven't finished, of course. Just want to see if we got any errors. Yes, we do. We have an equal sign somewhere. A rogue equal sign, I think. Where was that? I should look at the error a bit closer. Shadows parameter. Line 22. Shadows parameter. Shadows a parameter. Now that is an error that I'm not exactly sure what it is. Let's go ahead and Google it. Shadows a parameter C++. You have a variable as a parameter, which you're also trying to declare as a local variable. Oh, I see what it is. I'm writing the code in the wrong spot. That's what it is. Yeah. So all this code here, I meant to put in main. Where's my main even? I don't even. I lost main. It's down there. But here, let me tell you why that was an error. So the issue why that was an error is because I have A and B here, right? So I wrote it in the wrong spot. I was writing it in the magic square area, which when I meant to write it in main, but I saw the word MA and I just thought it was main. But anyway, the error itself, what it's saying is, because we have an A here that we're declaring as a local variable, we also have the variables A and B, which of course are address of them, but they're called A and B. So we have some sort of conflict between this A and this A. So, you know, you're trying to declare two things with the same name, so the compiler is complaining, and it's a little bit more complicated than that, but I think that kind of gives you an idea. So really, what I meant to do here is I meant to go ahead and put that in main. So where's my main? Main is over here. Like that. That's what I meant to do. So my apologies for that. Also, we do have a prototype for Magic Square, right? Yeah, so let's go ahead and move this to down here. And then, do we have a prototype for print? No, we don't. Let's go ahead and make one. Just so that we can compress things. Otherwise, you won't be able to see it on the screen here. Okay. And now let's move these prototypes to the top here. That way we have all the code that we're working on right now together. We'll even space this out so we don't get confused. Okay, so let me just run it and make sure I don't have any typos. Cool. Okay, and maybe actually let's just throw a return here so that it stops. Okay, cool. All right, perfect. Nice. Okay, now we're good. So we got our get area or get perimeter, and we got an empty function here. Let's actually look at see what happened here. So when we called LWPA, I want you to notice that L is 3 and W is 2 because we did set them as such. A and P, area and perimeter, we never declared them, right? They were never declared. I mean, sorry, we never initialized them. They were declared, yes, but they were not initialized. And then you got these random values. They're not very random. They have, I can see the meaning behind them. This is the max number that a certain short can be, and I believe this is half of the size of the size of an integer, I think. But either way, for all intents and purposes, they're random because they're not what we want. And this is a very good example on why you should initialize your variables. Because if you don't, and you try using them as counters or something, and you just think that the compiler, because other times it has put them as 0, and yes, we have seen a lot of times that they get set to 0 even when you don't initialize them. But you're gambling your life on something that is not guaranteed. That's going to happen. Of course, here it's okay because length and width, we haven't actually set them yet to the answers. So that's why I didn't initialize them to 0. I will go ahead and make sure that rectangle calculator gets you a value back. But if you wanted to be extra safe, you could initialize them here, okay? So anyways, let's go ahead and proceed to perform our perimeter and area computations. So first, let's do perimeter. So for perimeter, we are going to assign perimeter. Oh, and by the way, don't forget, otherwise, nothing will happen if we do not pass these by reference, because otherwise the data will be thrown away. In fact, let's actually run into that issue. But anyways, let's do perimeter. Perimeter is going to get called the get perimeter function. So we're calling a function within the function within the function. You're like, whoa, no, that's pretty normal actually. So don't be scared. Is this C? No, this is C++, but it might as well be C because at this level of programming, what you're learning is being disguised as C++, but like 90% of this is actually C for all intents and purposes. But it's C++. So anyways, get perimeter, and then we're going to pass in the same parameters that we passed in here, so length and width. Of course, those can be passed by value because we don't really need to modify them. We're just making a copy of them. If you really wanted to be super efficient and pass them as reference, you could, but you're not really saving much there, so it's not worth it. So you do that, and then let's just do that for now. This is one of them. Because I want to show you that basically you're still going to get garbage here. By the way, notice that this time we got a different garbage. Again, still garbage, random. In fact, run it again. Look at that. Talk about RNG right there. We're getting different random numbers there, huh? This one is kind of following a pattern, but this was just like all over the place, right? Because it's not initialized. But anyways, here, what we need to do to get perimeter back is we need to put an ampersand there. That is, of course, going to be passed by reference now instead of passing by value. And so now we are getting a bunch of panic. Why are we getting panic from this? Let's see. What did I goof? Of non-constant reference. What did we do here? Perimeter gets that. Invalid initialization of non-constant reference of type double from an R value double. Oh, yes. I see. I see what I did here. I put int here when this should have been double. And so what is happening is this. This is an integer, or at least it was before, right? And so because this was an integer, and then in the function I'm saying it's an address of a double, those things are not very consistent between them. And so the compiler is getting a little bit confused about how you're going from an integer to a double. And even though it's not showing you that error, what it's trying to tell you is that you're sort of trying to change one data type to another. So it's basically panicking. This is one of those areas where I would say that it's not that clear what's happening, especially if you're not familiar with this. So I froze a little bit. So anyways, once you do that, you're good to go. So now, of course, we are getting some weird and scary number for the area, but the perimeter is now 10. Is that correct? Well, let's see. What's 3 times 2? 6. And then 2 times 2 is 4. 6 plus 4 is 10. So yeah, that's pretty good. I would say that we are indeed good to go. Great. Let's go ahead and do the area. Of course, now we've learned our lesson that we have to put the ampersand, pass by reference, and let's go ahead and call our getArea function. So let's go ahead and do area, get area, length, and width, like that. And now we misspelled length somewhere right here. And now we can see that the area is showing as 6, which is correct because I don't know about you, but 3 times 2 is 6 in my world. So there you go. That is an example, albeit a weak one, but it's still an example of a function that takes 2 input parameters and returns 2 things at once. Whereas with a value returning function, you could return technically just 1 thing. With this kind of function, you can return 2 things. So power. Of course, we actually did end up using other functions to do getArea and getPerimeter, just to show you the example of simplifying your code even further by just dividing the problem into smaller problems, and also showing you a good example of a value returning function. And more importantly, realize that it is totally common and normal to have functions inside of functions inside of functions like this. In this case, we have 3 levels. We have main, then we go deeper, we get to rectangle calculator, and then we go deeper and get perimeter. Then we come back to get rectangle, and then we go deep again to get perimeter. Then we go back to rectangle calculator, then we go back to main, and then you're on the rest of the code. So this is nothing. You could go even deeper inside, like it's nothing. So start getting used to that. And it's important that you can follow the flow of the code. If you got the debugger going from that video that I posted, you can trace that progress as it goes on. So are there any questions? Let me know if there's questions. Otherwise, I'm gonna go ahead and see if there's anything I need to say. Function documentation. Now we got to the part where in the assignments you have to do the function documentation side. So that involves, now you know when you say it's there to talk about functions, you need to talk about what the inputs are. So any parameters that you're coming in, you need to discuss what each parameter is. Is it input? Is it output? Is it both in and out? Whereas it's actually use it, so like in the swap function, it was both the in and out for each parameter. This one though, the 2 first ones are ins and the last 2 are out. There's no mix and match. There's no in and out. There's either that in or out. So you also want to talk about the return type of the function, whether it's void, if it's value returning, what the data type is, and what the actual value it represents is. And you of course want to describe how your function actually works. And you saw that it's very convenient when you're typing in code here that it'll actually show you the documentation as you're typing your own documentation. So you can see why it's very useful to document code. So that's the discussion about documentation. Let's see what else we want to say. Suppose we would do something here with our calculator. Suppose that instead of passing it the length like this, 3, we actually pass 3 here. This is no problem. This will work just fine. But if we go back to the other one, if we go back to our magic square, let's run this again. Hold on a sec. There we go. Okay, we got our magic square here. Suppose that instead of passing left as a variable, we pass in a literal. What do you think is going to happen there? We're going to get an error. It's actually a similar error to the one we got when we had to double and the in mixed up. So here's the problem. 25 is a literal, which means it's being stored somewhere. Yes, there is somewhere that must store the 25 hard-coded in, but it's a constant. It's never going to change because it's a literal, and the compiler does optimizations for that. When you're passing by address, you pass an address to a function, and then you actually try to change stuff in that address. That works for the variable because variables, you are allowed to change stuff. If you try to pass a constant and then you try to change it, it's not going to let you because it's a constant, right? And you try to work around that situation by putting a level of abstraction and saying it's a function. It's not going to work. That's kind of what's happening here. You're trying to pass a literal's address, which can then be changed, and it cannot be. It shouldn't be. So when you're passing by reference, you can only pass variables into the function. That's a parameter. So if a parameter is a pass by reference parameter, you can only pass a variable, not a constant, not a literal. Whereas if that parameter, such as rectangle calculator, is being passed by value, then that's okay. You can pass a literal, you can pass a constant actually, you could even pass a normal variable because it's not going to modify any of them. It's just going to make a copy of the data, and that's okay. You can make all the copies you want. It's not going to modify the original one. So that's a little bit of a, I don't want to say it's obvious because it's obvious to me, but I've never programmed for a while. But hopefully you can see the reasoning why being very clear that, yes, if you're passing something by reference, which means you're passing the address of it, then that address better be modifiable, right? It's like, imagine you call the bank, you pass it, you give the phone number of the bank, that's your address. You call the bank to get the data or modify it, and the bank is like, sorry, you can't modify this. You don't have authorization to do it. And you're like, what do I do now, right? So you want to make sure that you're authorized to modify the data, and the literal or constant you cannot. So yeah. Let's see what else we want to do. Also, in that same token, you can pass an expression if you're passing it by value. Of course, you can't pass it by reference because, yet again, that expression needs to be stored somewhere temporarily. But I can do something like this. From a rectangle calculator, instead of passing length to be 3, I can pass 1 plus 2 there. And you will see that you'll get the same answer as before. You will get 3, 2, and then 6 and 10 for the perimeter and the area. What's happening is, first, the 1 and 2 get resolved to a 3, and then a copy of the answer 3 gets passed in. No problem because it's passing a copy. If I try to do the same thing here in the magic square, I'm going to run into the same problem. That 3 has to be sort of stored somewhere, and that somewhere is not really meant to be modified. So yet again, you're going to run into issues. So you can only pass by reference when you're passing in a variable, because you need to pass the address of that variable. Don't try passing other things like the result of an expression, a constant, or a literal. Okay, so that takes care, I believe, of chapter 6. Yep. I have a discussion of chapter 9, scoping. We already talked about scoping, but let's review it since we have the time. Also, I have Linux redirection. We talked about Linux redirection. There is one definition that we didn't talk about, and I'm going to go ahead and write it down here, and that is called batch processing. So let me go ahead and create a new program. We're pretty much done with functions though, so if you have any questions on functions, speak now or hold forever your peace, or however that saying goes. what am I gonna call this? Let's call this main CP. My lib, no, that has nothing to do with liberals. It means library. So please don't go political on me. Let me know. I'm still waiting for questions while I set this up. Come on, like it lags so long before I put the semicolon. Okay. All right. So no questions. 20 viewers apparently. That's okay. Just a quick question. Are any concepts on the function to be an exam? Nope. The last day of the content that's on exam is on Friday. So whatever we talked about yesterday, which was functions, and then today functions, will not be on the test. That will be on the final though. So yes. Test cuts off at file streams. So yeah. Yeah. I mean, maybe I did talk about Monday a little bit about concatenation, like string concatenation. That might show up in a test. I don't remember. It's just where you put two strings together, you know, by using the plus sign. But yes. Oh, by the way, good news. The TA took the test. And while I cannot disclose the exact time he took, he had tons of time to spare. So very good sign for you guys. Like you will have hopefully a lot of time to spare. Now, yet again, the TA is pretty smart. You know, he knows the material, but at least it's very possible to do the test in a very fast time. So we'll see. Would ARGC and ARGB be on the test too? Potentially, yes. I don't remember if I did use them or not. Honestly, like I would lie to you if I said yes or no. But because we covered it, I will cover myself and say that potentially yes. I want to say very likely. There's a question I'm thinking about that either uses Linux redirection or uses command line arguments. So one of the two. I don't remember which one. So definitely review that. If it is, it would be in the same sort of level as the homework assignment, where you get like a 0 or 1 or something, and you gotta swap them, like into an integer, and then check so you can see what the program does. Basically, there's a file streams. There's a file streams question on the test where you have to code stuff with file streams, and I can't remember if the argument is the file name or not. So, yeah. My dog is grumbling. I don't think she likes file streams. So definitely review them. I did go over them again yesterday in the beginning of class, so you can watch that too. Okay, so I want to show you one more thing about functions that is not part of the list of notes that I have, but it's useful to know. And also makes you understand things better. And then from there, we can talk a little bit about scope, batch processing, just to kind of reiterate those themes. I do want to write one definition here. It's just, I don't know if I ever mentioned it. Nope, that pasting didn't work. I'll copy it. And that's the idea of batch processing. So batch processing is when you put all your input in a file and you create a program that runs through that. That's basically what Linux redirection does. So when you put, Linux redirection replaces the idea of manually typing in stuff, or instead of CIing into a terminal, CIing into a file. That is done usually so you can process things faster, such as grading your assignments. And the term that is used to define that is called batch processing, because you're doing a batch of things at once. So yes, I don't think I ever mentioned that by name, but that's what that is. So I should send this one to Dolly because I know Dolly wanted Linux redirection stuff. Scoping. Remember global scope, that's the big scope. That's where you usually write your functions. Local scope is within the block. A block is defined by the curly brackets. And yep, that's all I really want to say about those. So we can go ahead and terminate that. So really, we completed topics 8, 9, and 10. Very good, very good. Let me see something here. We're getting close to the end. We already did file streams. I have a thing on strings. Let's see if there's anything useful on strings that we could cover. Length and size. We already talked about using length and size to find the length and size of a string. The empty string, by the way, when you hear the word empty string, is this. It's 2 quotes with nothing inside. However, the empty string does contain a single character, and that is a line feed, which is usually kept at like, oh sorry, not a line feed, a null terminator. All strings are null terminated. Null is defined by a \0. What that means is that when you're processing a string, the way the computer knows how to stop reading in C is it sees a null terminator and it's a flag to stop printing out. It's a remnant from C that all strings are null terminated. So if you ever hear that term, that's what it means. Just a fun fact. I have a question. Would the encryption decryption assignment have been a batch process since we input a file and then process all the text in batch? Yeah, it's sort of batch in the sense of processing the text, but batch can apply to bigger things. Like you can batch process a bunch of files. So it's kind of like saying like divide and conquer sort of concept, where like if I got 10 homework, let's say I got to grade 10 assignments, me grading them all together could be set up batch processing. I could also say I'm batch processing a single assignment by grading multiple parts of it together, right? I could also say I'm batch processing all of my classes by grading all the assignments from all classes together. So it's sort of a scale thing. So yes, while yes, you're right, the most popular definition of batch processing is when you set up a program that can read input and then you can run it again with different input, and you sort of set those up in order so you can go one at a time, which is kind of how grading works. So yes, in a way, kind of. So, all right. Cool. Let's see if there's anything else that I want to say about the strings. This could also help. Get line we already showed. I talked about the ASCII characters. To lower and to upper. Oh, okay, so yes, we'll talk about those eventually. Okay, so I'll leave this one. Cool. All right. So first, let me show you this header thing, and then if we have extra time, then we'll do any of those random things. Because I don't want to start a major topic like arrays until after the test. So, okay. So what I want to show you now is how to create your own little tiny library. I should have not called that .cpp actually. I should have called that .h. Now that I just realized that. So, yeah. Okay. mylib.h. Let's close that. Have a message from someone saying they're trying to open the test, but the test is tomorrow, so oof. All right, anyways, okay, so suppose that you wrote this really amazing function such as my magic square. So I guess I should reopen that. Let's just do gedit for that. and you're like, this is so cool, I want to keep it for posterity. Oh, that's lucky. So we're going to copy that, and we're going to save it in this file called mylib.h. It's not .cpp, .h actually. I guess this guy's a rogue part of the code that kind of jumped in here. Okay. And so there we go. We got a little function there. We need to put these in here so that I think we will need to put those so we don't have to use the namespace thing. Oh, no returns there. I thought it was waiting for a second. Okay, so we got our code, and the reason I added all these STDs is, if you remember from day one, if you don't using namespace STD, as we always do what we say on programs, like, well, if you don't use this thing, then you basically have to put std : in front of everything that has like std IOStream stuff, such as couts and endlines or cin. So I added it in so I don't have to put it in. And then let's go ahead and we'll probably have to include IOStream here. No, let's not include it and see what happens. Dog. Let's include our little custom library in here. How do we do that? We write include, we put quotes, and then we put the name of the library. Like such. Doing this will allow us to compile and run the code. Better yet, I can call the magic square function from here. So let's make L get 4 and R get 7. And then let's go ahead and call them out just to get rid of this. If you're using your namespace STD, do you still have to do STD out, or can you not do it? No, you don't have to do it. Oh, in the library? It depends on how the code gets run. If they're using namespace STDs before they include, I think you'd be okay. Otherwise, you would not be okay. So, yeah. Oh. Copying and pasting is a dangerous task if you're not careful. Okay, there we go. The function has been used. So, yes. What I did was I used include. Notice that I didn't use the less than greater than signs. I used quotes. And I said my lib.h inside those quotes. So it's a little bit different when you're doing your custom libraries. That's just the way it works. And then I can use the code just as if it was right there. The way I make my lib.h is I just put in the code as needed. And as you can see, everything worked fine. So that's it. Let's call it a day there. That way you guys have an extra half an hour, all right? So I'll be on Discord if anybody has any questions, all right? So, cool. because I'm not feeling too good right now. So anyways, I wish you guys good luck with the test. Like I said, I'll be on Discord for any Q&As, and I'll be online tomorrow. All right. Okay then. I'll see you guys. Thanks for watching.